Now this band bending, what it will happen, eventually the mid band energy gap, or you can say EI, becomes smaller than EFS, Fermi level on the surface, which means that the substrate semiconductor in this region now becomes which type? Now the substrate becomes N type, because in P type you have E above EF, that is your intrinsic level is above the Fermi level. When your intrinsic level, you can say this is your Fermi level and this is your intrinsic level. This type of configuration is for N type and this type of configuration is for P type. Now when you see at this point, you can say the intrinsic layer is bending below the Fermi level, or you can say the type is now changed to the N-type semiconductor. Now within this thin layer, the electron density is larger. You can see large number of electrons are accumulated over here, right? Electron density is larger than the majority hole density. Why? You have P-type of semiconductor. Here you have majority carriers, but the concentration of electrons are more as compared to the majority carriers, since the positive gate potential attracts additional minority carriers from the bulk substrate to the surface of the oxide layer. Now the N-type region created near the surface, you can see this type, by the positive gate bias, this is called as surface inversion, and the layer is called as inversion layer. Again, the N-type region created near the surface by which type? You can say by the positive gate bias is called as inversion layer, and the condition is called as surface inversion. Is this point clear? Why? Because of the concentration of electrons at the edge, we are getting inversion layer, and this inversion is called as this, what you can say, this condition is called as surface inversion. The thin inversion layer on the surface with a large mobile electron concentration can be used for conducting current between the two terminals of the MOS transistor. We can say because of the large concentration, the current can flow. The surface is said to be inverted. Which surface? This surface is said to be inverted when the density of mobile electrons on the surface becomes equal to the density of holes, because you can say the electrons are the minority carriers. When the mobile electrons on the surface become equal, we can say that the surface is inverted, and once the surface is inverted, any further increase in the gate voltage after inversion, if you increase the gate voltage, what will happen? It leads to an increase of mobile electron concentration. The concentration of electrons increases, but not to an increase of the depletion depth. That means the depletion depth remains constant at a particular layer. Thus the depletion region depth achieved at the onset of surface inversion is also equal to the maximum depth, which remains constant. Now very important point, the criteria of conducting surface inversion layer through externally applied gate voltage bias is an essential phenomenon for current conduction in MOS transistors. So this inversion is required for the working of the MOS transistors. Thank you for watching in 5 minutes.